Today we're going to make thermite, and I'm going to show you step by step how to make rust. Like rust you can see grows on old fences and stuff on the iron, but I'll show you a very quick way, which only takes a day or two to get like quite a bit of rust, considerably. And then dark aluminum powder. So this aluminum is like flour, and it's so fine that it's clumping together. But this aluminum has to be extremely fine and covered in carbon, so I use charcoal, so that it does not react with the oxygen to create aluminum oxide. Fun fact about aluminum, actually it's one of the most reactive elements, it just creates an oxide. So as long as you don't let it oxidize when you stick it in a ball mill to grind it up into this fine flour, then it's going to become a very fine powder that's extremely reactive. When we combine the aluminum with the iron oxide and add heat, the aluminum takes the oxygen away from the iron oxide, making aluminum oxide, generating a lot of heat and making molten iron and molten aluminum oxide. So this is a very heat intensive process, and you should be very careful doing this even if you do it at all. So anyhow, the ratios for these, if you're going to want to have 2/3 iron oxide and 1/3 aluminum. And then you're just going to combine these and make sure you mix them extremely well so that you get a good, thorough reaction. So I'm going to mix them into this glass. Back. And we have all of our powder made, or thermite, so it's mixed really well. You want to make sure it's mixed really well. If it's not mixed really well, then it's going to be extremely hard to ignite and probably won't ignite at all. So now I'll show you these reactions taking place and how much heat they generate in the end product, and then I'll explain and show how to make the iron oxide and the dark aluminum powder.
Is that pretty light? Ooh. It's stinky.
Oh, here it goes.
Hey, look at that.
Okay.
Hashi, no! Close the door, somebody. Holy. Whoa, look at that, Kai. It's like a smoke bomb.
This is great. Here comes the fire department.
Just keep it filming. This is awesome.
It's filming.
Oops, I did it again.
Oh, the tin is self-destructing. Look at it. You can see it.
It's a
burning.
smoke bomb. How'd you make a smoke bomb out of that?
James, don't get in front of the film camera.
James.
Oops, I did it again.
Holy smokes.
Holy smokes is right. I think the neighbor's going to call.
Wow, 200 grams of thermite.
Look at that. And the tin is glowing.
Maddie, I don't know how good that is to breathe in.
I'm not breathing it in. Uncle Jeff. Everybody is.
Oh, good.
There,
That looks pretty red hot.
Stop it. Just keep it filming.
That's cool.
That can is red smoking hot.
That's white.
It's
Dad, it's white.
Okay.
Here, let me.
It's still filming.
White. Hey,
I'm
guys!
I'm going to get a close-up.
It's pee-pee.
Okay, let's go really close.
Touch the...
Okay, let's go
See
see.
who can survive.
There we go.
No one can. Holy. It's like red down.
Holy, look at that glowing molten mass of iron. Cooled, and I took apart the tin can, And I'm back inside, and we're left out with these chunks of aluminum oxide here. They contain bits of iron in them, probably. But what I'm really happy with is the ingot of iron that I got out of that. So this thing is solid iron. It's really, really, really awesome. I was so happy to figure out that I actually was able to make a bit of molten iron from that reaction. I don't have a magnet on hand, so I can't show you, but trust me, this is iron. It's pretty awesome. So now we'll go on to how the ball milling works, and to get the very fine aluminum powder, and how to make So this is a fairly simple process. You're going to need a DC power supply. I actually have a variable power supply, as you can see here, where I can vary the voltage and the current to what I need. But any power supply will work. But it's ideal to have a variable voltage one. So anyhow, you're going to want to use a glass bowl or a plastic container that you don't care about. But glass can't stain, which is very useful for this because you're going to get rust-colored material in the end. So you are going to need a large piece of iron, 2 wires to attach, and then just a strand of iron something, I don't know. I just used a piece of bare iron wire. Anyhow, you're going to want to configure them so that they hang over the edge of the bowl and that they're about parallel to each other so that the electrical resistance between this one and this one is about the equal all the way along. That way, we're going to get equal distribution so that the iron can dissolve throughout the entire nail. If we say had it angled here, then it would be much easier for the electricity to get across here, so we would actually corrode it here, and this part would all fall down, and we'd waste a bunch of our iron, which we don't want to do, because we want to turn it all into iron oxide. So, what we want to do is have it so that the negative electrode is on the iron. So, this is going to generate the oxygen over here, and this is going to generate the hydrogen. There's no use for the hydrogen one, so we just let that bubble. But the oxygen one, you want to adjust your current until we don't see any bubbles here. This is making it so that the iron is combining with the oxygen, actually making iron oxide. Very quickly, you're going to see your water start to turn brown. But this is barely any iron oxide. We're going to let this run for about 2 days, and then we will have a thick pool of iron oxide at the bottom, which we can then filter off. The electrolyte for inside of here is a supersaturated solution of salt water. We want to use salt because it is ideal so that we don't electroplate the iron onto this over here, which could create very beautiful crystals, but we don't want to do that. So anyhow, when you have all of your iron oxide here at the bottom, you're going to filter it off using a coffee filter or something, and let that sit for about a day, and stick it on a cookie sheet that you really don't care about. Like, I use an old rusty one to dry out my iron, but yeah, make sure you don't care about it because it's not going to look pretty ever again. Anyhow, then you'll stick it in the oven at about 500 degrees Fahrenheit for about 15 minutes. Monitor it so that you make sure you don't burn your house down. Anyhow, so when you've done that, then you should be able to scrape it off and you will have a fair amount of iron oxide. The bigger your tub is, of course, the longer you can let this run, but once your 2 electrodes are submerged or you've run out of iron to turn into iron oxide, you must stop. But this is practically an infinite process, which you can make plenty of iron oxide for thermite. Dark aluminum powder, it's actually quite simple. We just need some aluminum foil. So you're going to unroll some and rip it into fairly big pieces, perhaps 2 inches by 2 inches. So they're pretty big, and you're going to need a blender. This blender you can never use again for food because it is like, aluminum is really bad to ingest. So anyhow, you're going to want to buy one from the dollar store or secondhand store or something that's really, really cheap. I actually have a magic bullet here, but it's secondhand and it didn't cost that much, and I use this solely only for experiments. So you're going to want to fill this full of pieces of aluminum, stick it on here, and grind it for about a minute until it is coarse aluminum sand type stuff. Then you'll just put it off to the side and continue doing this until you have about a cup of this stuff. Once you have a cup of aluminum sand type stuff, you're going to want to get about 2 teaspoons of charcoal powder. Now, charcoal is one of the easiest things to make. You just have to burn some wood, take that burnt wood, and grind it up. Now, in a future video, I probably will show how to make good quality charcoal that is used. Well, it's made inside of a can. Anyhow, I'll probably do that in a future video, not this video, because I don't have time, and it's the middle of winter right now, and it's not so easy to light a fire. Anyhow, once you put your charcoal in, then you're going to want to mix it all up and stick it in a ball mill. I'll probably build a ball mill in a future video also. At the moment, I just have a rock tumbler, but that works perfectly. But anyhow, you're going to want to let your ball mill run with glass marbles or lead balls. I use glass marbles, not lead balls. Lead would work way better, but I don't have a bunch of lead balls hanging around, so I use glass. Because if you use steel, there's a potential for a spark, and if there's a spark within this aluminum which has not oxidized, there's a huge potential for either an explosion or a massive meltdown fire type thing. And this could totally wreck your house or just your ball mill, but anyhow, you don't want to risk this, so you have to be really careful. So anyhow, using glass, you're going to grind it for about 2.5 weeks. You want to check on it every now and then to make sure everything's running smoothly. And if any of your marbles break for some reason, mine didn't, but if they do, you'll probably want to remove them. Anyhow, so when your aluminum is finally finished 2.5 weeks later, it should be about the size of like flour. It's going to start clumping together. It's going to be perfect, and it's going to look more on the dark side, which is why it's called dark aluminum powder, due to the charcoal that's covered it all. This is pure aluminum. It has formed no oxide layer, which makes it extremely reactive. This can be used as flash powder by throwing it into the air and inducing a flame. But for this video, and project specifically, we're just going to use it to react with the iron oxide. So, when you have finished these 2 steps in making these 2 elements, you can combine it. Have fun making your thermite.